finish up these related rates here. A couple more examples for you. Hopefully. So we have a 13-foot ladder. Read the problem. 13-foot ladder leans against a vertical wall. The lower end of the ladder is being pulled away at a rate of 2 feet per second. How fast is the top of the ladder coming down the wall? At A, the instant the top is 12 feet above the ground, and B, 5 feet. We'll just concentrate on the first part. The second part changes some values, but the process is already done for us. So draw a diagram. Here's the wall. Here's your ladder. Right, here's the base. So you see it creates a triangle. Right. So what we're doing is we're pulling this point away from the wall. Okay. As you pull it away, this point is going to be moving down the wall. Right. You want to be thinking of stuff that means this quantity is changing. So let's label that with a variable. Let's call that X. This quantity is changing. Let's call this Y. And then this is the length of the ladder. Right. Now, as we pull this away, and this is going down, this ladder is staying fixed. We could call it Z, right? But realize that Z is equal to, this is the 13 feet. And since this quantity is not changing, dz dt, the rate of change of that quantity, is 0. All right, and this is going to simplify some things because when dz dt is 0, that tells me I can plug in 13 before I differentiate. All right, let's see what else we have. The lower end of the ladder is pulled away at 2 feet per second. So that's this quantity changing. So I have dx dt is equal to 2, all right, feet per second. And I'm asked to find how fast the top of the ladder is moving down the wall. So what I want to know is dy dt is equal to question mark. That's what I'm after. And keep in mind, this is going down the wall. So what do we know? That this quantity right here, dy dt, right, is going to be less than 0. Okay. All right. Now, what makes sense in the context of this problem to relate x, y, and z? Well, I would think clearly x squared, Pythagorean theorem, plus y squared equals. Now, in this case, when in doubt, you can always just put in z squared, but it's going to simplify if you plug this in, right? This is a case where let's plug in 13 here, all right? But you have to make sure that whenever you plug in before you differentiate, that this quantity is not changing, and this 13 is staying fixed the whole time. So now I differentiate with both sides with respect to t. Take the derivative of x squared with respect to t. That's going to be 2x dx dt plus 2y dy dt equals 0. Okay. Now I want to, ultimately I want to solve for dy dt, but might as well plug in first. Okay. X 2 dx dt. All right. Or sorry, x I don't know. Dx dt is 2. Sorry. When the top of the ladder is 12 feet above the ground, so I do also know y is when y is 12. So I know y. So the only thing here I don't know, right? This is what I'm after. I'm after this value, dy dt. Do I know y? Yep, check. Do I know dx dt? Yep. What I don't know is x. I got to find x somehow. All right. And you can find that by, well, do you have anywhere else that you see x? Yeah, up here. X squared plus y squared equals 13. I know y is 12, so that means x squared plus y squared, 12 squared, 144 is equal to 13 squared, 169. X squared equals 25, so x equals 5. So I could find x. Now I plug in 2 times 5, 10 times dx dt, 2 feet per second. All right, plus 2y, y is 12, 24, dy dt equals 0. Solve for dy dt, subtract the 20 over, divide by 24. So dy dt would be equal to negative 20 over 24, and the units would be feet per second. Okay, done. Makes sense. It's negative. All right. So this point, all right, as this point is being pulled away from the roll at 2 feet per second, Okay, at the moment that this point is 12 feet above the ground, this point is moving down the wall at negative 20 feet per second. All right. And the only thing that changes here is now y is 5. So that would be 25 here. We'd solve for x, and x would be 12. Okay. So that's it there. Let's move on to one more here. So here's one. Yeah, sand making a pile, right, in shape of a cone. You're told the radius is always equal to twice the height. If the sand is poured at a rate of 20 cubic inches per second, how fast is the height changing at the time the height is 2 inches? So this is one where, well, we could draw a diagram. Here's my cone, my conical pile. Okay, I think we agree. Right, you got height, have a radius. And read through here. Radius is always equal to twice the height. So the radius is always equal to twice the height. If the sand is poured at a rate of 20 cubic inches per second, this is a rate. So let's label it. It's a rate of change of what? Volume. So I'm told that dV dt is equal to 20 cubic inches per second. How fast is the height? Okay, let's see if this works. I'm having trouble with this whiteboard app. It's being funky. So let's try to continue here. Where we left off, we had radius is twice the height. Rate of change of the volume with respect to time, 20 cubic inches per second. How fast is the height changing at the time the height is 2 inches? So we're after dH dt equals what? When h equals 2. Okay, so that's everything we want to find out. So now we need a equation, something that relates stuff we have here. We have stuff about height, volume, radius. And this one we're going to do kind of two different ways. So the first way would be, all right, well, volume of a cone, 1/3 pi r squared times h. There's our equation that relates volume, radius, and height for a right circular cone. Then we're going to differentiate here. Derivative of v with respect to t, dv dt. Then here we have pi over 3, and then r squared times h. So we're going to have a product rule. Pi over 3 is our constant times, now product. The derivative of r squared with respect to t is going to be 2r dr dt. So 2r dr dt plus r squared times the derivative of h, which is dh dt. Okay. So there's everything that our derivative of v with respect to t and everything that we have here that we want to know, want to find stuff about, what we know. Well, one way to think about it is dH dt. So I go over here and say, here's dH dt. Let's put a little box around it. There's what I ultimately want to solve for. So do I know values of everything else, right? Do I know dV dt? Yep. No dV dt. Do I know r, what the radius is? I don't know r. All right, let's figure that out. H, yeah, no h. Do I know dr dt here? No, don't know dr dt. Do I know r? No. So here we want to know dH dt, but in order to find dH dt, we still need to do some work to find r and dr dt. Well, r is simple enough. When h is 2, we're told that the radius is always twice the height. So if h is 2, then r must be 4. Okay, so when h is 2, r equals 4. So that means, yeah, now I know r here and I know r here. But now dr dt. Where do I have dr dt? I had dr dt. And there's nothing up here in the description about the rate of change of the radius with respect to time. So here's where you got problem solve a little bit. Say, well, I don't know dr dt, but what is dr dt? Dr dt is nothing more than the derivative of r with respect to t. Well, over here, I have r. I have r in an equation. So I could take that now, take the derivative of this. So I could take the derivative of r equals 2h, which would then be equal to dr dt is equal to 2 times dh dt. So I can now sub all that in to there for dr dt, which now includes dh dt, which was what I'm trying to find. So now we have everything we need. Okay, dv dt. What's dv dt? 20 cubic inches. Okay, pi over 3 times 2 times r times h. 2 times r is 4, h is 2. So 2 times 4 times 2 is 16. 16, right? This is all 16 here, times dr dt, right? Here's dr dt, times 2 dh dt, which is 32 dh dt, plus r squared, 16 dh dt. All right, let's get rid of pi over 3 by multiplying by the reciprocal. So that's going to be 60 over pi equals 32 plus 16 dh is 48 dh dt's. And then lastly, divide by 48, and we have our answer. 48 over 60 pi, or 60 over 48 pi. And the units there would be, well, this is a rate of change of height. So the units would be inches per second. Okay. If we put the units in here and do a dimensional analysis, like the stuff you do in chemistry, we would come up with that units. But we know, everything in here we could and just put the units in at the end. So there's one way. Okay. That's a bit of a mess, kind of complicated. A lot of times you run into trouble because you try to, you don't know where to find dr dt. So that's one option. The other option, okay, so here we have v equals pi over 3 r squared h, right? So in this one, we've got three values. We have v, we have r, we have h. If we look, what do we know most about? What are we told mostly about and want to know stuff about? Well, I'm told about v. I'm told stuff initially right away about h. I want to know stuff about the rate of change of h, so I mostly know about v and h. Okay? So if you mostly know about v and h, then maybe one way to do this is to get rid of r in terms of v or h right away. And that's simple enough in this one because we're told that the relationship between r and h is that r is equal to twice h, right? R is equal to 2h. So now if I take 2h and sub in here, I get v equals pi over 3 times 2h, there's r, squared times h, which is then equal to, square this, so you get 2 squared, 4, so 4 pi over 3, h cubed. So now my volume becomes 4/3 pi h cubed. Now this is a much simpler looking equation, and then look what happens when I differentiate this with respect to t. I get dv dt equals 3 times 4/3, which is 4 pi h squared times dh dt. And now this is what I'm after. That's what I want to solve for. So all I need to know is what dv dt is and what h is, and those were given, right? Well, won't let me go back. So dv dt was 20. All right, equals 4 pi times h. H was 2, right? 2 squared times dh dt. And then we could solve here. 4 times 4 is 16 pi. So divide by 16 pi. Get rid of all that. There's your dh dt, right? And then the units would be inches per second. And that's what the other problem reduces, right? The previous one reduces to. But like I said, I'm trying to click here to go back. It's not letting me. So that's the options there for doing something like that. All right. So there's a couple more examples. You got to read through it, write stuff out, try to write neatly. And in the end, write formalize your answer. dh dt equals 20 over 16 pi. And then it's inches per second, right? Done. Call it a day. All right. So check that out. Let me know if you have any questions on any of that.